This voice over PowerPoint provides an introduction to behavioral research designs. All of you will have an entire class on research designs associated with applied behavior analysis, but this one unit's designed to help you understand the logic behind it, so we'll be better able to read some actual research as we talk about interventions. Think back to the 7 characteristics of applied behavior analysis. Those are important concepts to remember. Now, one of those is being analytical. Of course, it makes sense since we're talking about applied behavior analysis that we would be analytical. So far, we've really talked in detail about one, and then this week we're going to talk in detail about another, about 2 ways to be analytical. The first way, we just finished Module 1, is the idea of functional assessment. To analyze the relationship between behaviors and environmental variables, antecedents and consequences, in order to understand if they're functional. So what, if you will, purpose does a behavior serve? What is the reinforcer that's maintaining a behavior in the presence of what antecedents? That's a functional assessment, and that is being analytical. I personally believe that's the prime idea of being analytical. But the second idea is incredibly important to the idea of being accountable and to the idea of being an empirical research-based discipline. And that's the application of research design. ABA, single case research design, analyzes the relationship between behaviors of interest, whether we want to increase or decrease behaviors, and some change technique or intervention. So the idea is there a functional relationship between a problem behavior and some intervention that we use to evoke change? Obviously, if we want to be effective, which is the idea of promoting important change with people, then we have to be able to assert that there was a relationship between what we did and what results we got. And that's the idea of a research design. ABA, like every other scientific discipline, deals with 2 kinds of validity when we're talking about research design. The first one is the idea of external validity. If we do research, if we produce research that indicates there's a relationship between some type of problem and a specific intervention, then what can we generalize the results of any particular study? For example, in ABA, if we have a single case preschooler whose behavior of a certain type we're able to modify successfully in important ways, could we generalize those results to every other preschooler with a similar problem? The answer, in short, would be no, but there has to be some set of guidelines about how we do that. ABA allows the use of single subjects, so that in order to talk about external validity, we have to have multiple studies of a similar sort in order to be able to assert that some procedure is generalizable to a population. Internal validity is really the issue at hand right now. And that's the extent to which we can say with some certainty that the intervention is responsible for the behavior change and not something else. If you don't have internal validity, then you really can't have external validity. But you can have internal validity without external validity. So if we can't, by using a design is the way we do this typically, if we can't assert that the intervention is responsible for the change, then we can't make meaningful statements about functional relationships. So the first thing in the study is we have to set up a design that rules out other things that could have changed the behavior besides the intervention package. This is the same for any kind of research, medical, sociology, and applied behavior analysis, psychology, any kind of research. So what's a confounding variable? It's really a variable that basically could have been responsible for a change as well as the intervention, and without a design we can't rule it out. For example, with working with children, in many cases children's behavior changes as the process of development occurs, and so did the intervention cause a change in students' behavior, or would that have occurred anyway, just in general developmental terms? There are many examples like this. So we have to eliminate the possible effects of confounding variables by using a research design in order to demonstrate experimental control. Experimental control simply is the idea of demonstrating a functional relationship between interventions and behavior change. I think it's important, as the book does, obviously, that we talk about some of the assumptions. Let's talk about assumptions about behavior first. First off, behavior is an individual phenomenon. We study behavior at the individual level, not the group level. Behavior is continuous. It's not like it happened, it never happens again, but it's ongoing through time. We're always behaving in one way or another. Behavior changes over time and settings. In order to analyze it appropriately, even with behavioral research, we have to measure behavior the same way over time so we can look and see how it might change. We obviously assume if we're behaviorists that behavior is functional, that it's determined. Generally, we assume that behavior is primarily determined by learning history. And when behavior changes from time to time in a setting, we believe that the responsible elements for that variability is not within the organism, within the person, but to a large extent outside the person. So behavior is a function of its learning history, of previous consequences in similar settings, as opposed to internal variables like personality constructs and what have you. This is an important assumption of behaviorism, applied behavior analysis, and of course then it becomes an important assumption about behavioral research design. So ultimately we assume behavior is influenced primarily by external things, and within a context of a design, those external things can take on several flavors, if you will. First off, behavior change could have been influenced by the independent variable. That means the intervention that we're looking at, and that's the idea, is to rule other things out so we can attribute important change to the intervention. But something that we don't know about or didn't control could also have influenced behavior. My research is almost all done in classrooms, and there's many things going on at one time besides any particular intervention, and those things also could influence behavior. So if the intervention can't demonstrate behavior change beyond those variables, then we'll never know how well it works. And in fact, there could be something completely outside of the research setting, some family issue, some illness, something that was not even occurring in the problem setting that does influence behavior. But again, we want to demonstrate that our intervention can change behavior. We can demonstrate a behavior intervention change beyond this kind of noise, if you will. Not that they're not important or real, but that the intervention is responsible for most of any change that we see. It's the predictability of the change that's of interest. If I do it this time this way, the prediction would be if I do it similar problems in the future the same way, I should get similar changes. It's an important idea. So variability is a result of environmental influence. Some of those influences are things that we control, the independent variable, if you will. So to the extent that the intervention is present or absent, behavior should vary. But a methodology of any research, and the methodology in ABA, is to search for what's causing changes in behavior. In practice, again, we want to find treatments that are robust enough to overcome other kinds of variability, and not just overcome them, but produce significant and important changes. It's the idea of being effective. So what are the components of an ABA experiment? Unlike traditional, for example, psychological educational research, we don't have to have a group of subjects. We can apply ABA design successfully. In other words, you can have an internally valid study with just one subject. It could be more, of course. We have to have at least one behavior that we want to change, one dependent variable. There could be more behaviors in which we have an interest at the same time, but we have to have at least one. We have to have at least one problem setting. A child could be misbehaving at home, at the playground, and at school. And maybe our research only is going to be done in school, and so whether or not his behavior would change in other settings is an experimental question. But we have to have one setting of interest. And we have to have at least one intervention condition. Almost always, in almost every kind of research, into behaviors at any rate, the independent variable or the intervention is a package of things. It's not just one single small thing, it's a package of things. So we are always going to be evaluating an intervention condition that itself is a package of individual elements. We have to have some way to measure behavior. And since we're measuring behavior across time, then we have to be able to say, to prove, if you will, that we've measured behavior the same way each time we did it, so that it's the behavior that produces the numbers and not measurement changes. Think back to last semester and that's the idea that we're measuring the behavior of clients, not our own measurement behavior. Data quality over time, accuracy, reliability must somehow be assessed. So an applied behavior analysis study has to have a method to assure that our measurements are consistent and produced, or at least we can infer they produce accurate measurements. We have to have some system for measuring whether or not we actually implemented an intervention. If we didn't measure our implementation, then we can't really establish a functional relationship between intervention and subsequent behavior change. That's the subject of the article that you're going to read this week about treatment integrity. It's called treatment fidelity, treatment integrity, treatment implementation, a variety of things, all of which imply that we have to have some systematic way to measure that implementation as part of our experiment. We have to have a clear, consistent way that we implement the independent variable. For most applied behavior analysis studies, we end up with some sort of script, if you will, or a checklist that defines the elements of the intervention so that we can check it. And then finally, we have to have an experimental design within which to manipulate the independent variable, and design allows us to rule out those confounding variables that we talked about a minute ago. And again, we're not going to try and teach you this one unit, everything about experimental design. Graduate students often have 3 or 4 courses in design and have experience in doing it, but some fundamental rules that you'll understand. One of them is we only change one thing at a time. You can change more than one thing at a time, but then you don't know what might be responsible for changes in behavior. So if we want to be able to establish clearly a relationship between what we do to someone, how their behavior changes, we should change just one thing at a time. And if we're investigating a package, which I've said earlier, we almost always do, then we should make sure the entire package is presented or withdrawn each time we manipulate it in order to understand the relationship between changes and the intervention. In school, for example, again, packages are the rule, not the exception. And sometimes we don't know which part of a package might have been effective or not. Just think about reading, for example, a reading curriculum. What part of a reading curriculum might be responsible for improvement in reading? It's hard to say. It's a whole package. Some parts might have been necessary, other parts might have not been. And it's just something that we have to live with. I think this is clearly explained in your textbook, but I'm going to spend some time talking about it, and that's the idea of steady-state strategy baseline logic. The 3 components of this, and these are the 3 components of any experimental design and applied behavior analysis that we have to be able to clearly articulate and explain, and it's part of being able to say that the treatment's responsible for changes. And these are prediction, verification, and replication. There are other ways of looking at applied behavior analysis research, to be sure, but this is a useful way, I think. So you're going to be responsible for being able to talk about and identify the aspects of design that have to do with the notion of prediction, verification, and replication, and I'm going to talk about those here in some detail. The concept of a baseline is an important notion in applied behavior analysis and in accountability in general. Not all ABA designs require a baseline, but the ones we're going to look at in this class do. Baseline sort of serves as a control condition. We would say it serves as a within subject control condition. It's a condition where whatever's been going on before is still going on, and the intervention is not present. We look at baselines, and this comes from last semester, and we talk about things like level, trend, and variability, like any applied research, any data series, any time series. Baselines serve several functions. The first one is to verify that there is in fact a problem. I've had cases where there was an interview, things seemed really bad, began to collect baseline data, and the problem was not apparent. So one function of baseline is not just for research, but to verify in fact that there is a problem. We might be able to collect information during baseline that helps us in our functional behavior assessment. If you're observing behavior, for example, you can observe antecedents and consequences, and you may remember that's part of a descriptive functional behavior assessment. And baseline doesn't necessarily mean that there's nothing going on. In school settings, there's always something going on. It just means that the particular intervention, again, that's called an independent variable in which we have an interest, is not present. So we're going to establish a baseline level of responding, and we're going to use that as something to compare against when we talk about changes and making decisions about changes. Baseline also allows us to see how bad things are, so we can set goals. While research doesn't require that we set goals, good practice requires that we always set a goal for our intervention before we begin intervening. And that goal should be something that the significant people involved have agreed to, that it's a meaningful goal. Just for a quick review, you may remember these from last semester. These are baseline data patterns. And so we talk about, again, level, trend, and variability. A is not a very variable behavior. It's somewhat flat. There's no trend. B is an upward trending, but not very variable within the idea of a trend. C is downward trending, again, not very variable. D is a very variable, but apparently, as near as you can tell, not a trending kind of baseline pattern. So when we look at, for example, B and C, if we just looked at level, the level of those two things, the average is probably the same, but they're clearly not representative of the same kind of behavior pattern across time. So in order to understand our baseline, we have to consider all three of those: level, variability, and trend. So let's take a look at the elements of logic, of baseline logic, that allows us to make these inferences about whether or not interventions have been effective. The first one is prediction. These figures come generally from your book. I've added some text. So the idea of prediction is, we've got a baseline. What would happen if we didn't do anything? What would we predict would happen? Well, we will predict that the same kind of pattern would continue. So in this case, you can look at the solid points. Those are actual data. And if I ask you without saying anything else, what would you predict would happen across the next 2 weeks? Your best prediction would be, well, the same thing has been happening. And that's what those open circle data represent. That would be a prediction of what continued data would look like if we did not intervene. Your book talks about the idea of affirmation of the consequent, and I'm not going to ask you this on a test, but it's an important logical notion when it comes to ABA kinds of research. It's a way of looking at it. We would ask the question, if the independent variable didn't happen, we would assume that the behavior would not change. So if it didn't happen, then B, the behavior wouldn't change. And that's what that would look like. But if the behavior does change, then we would begin to assume that since our prediction was not valid, that there's something responsible for that change, and it might well be the independent variable. This is not sufficient to say that it is, but it might be. So if the treatment's responsible for the change, then our prediction from baseline would not be accurate. It would change in a certain way. So here's an example of, we'll talk about the affirmation of the consequent. This is also something else in a minute, but look at the solid circles. There's baseline. We would predict, there's our prediction there in the box. If we didn't do anything at all, that's what it would continue to look at. But we did a treatment, and look what happened. So the actual data differ from the prediction, and therefore there's a possible functional relationship between the intervention and the behavior change. But there are other things we have to be able to assert in order to get internal validity. One of them is called verification. So we predicted that behavior would be at baseline level if we didn't intervene. Then we intervene, and lo and behold, we have a change. So we want to verify that our original prediction was true. That's what we have to do in order to begin to say there's a relationship between the intervention and behavior change. And you can look and see that in this case, when we went back to baseline, in other words, we took the treatment away, that it went back to baseline levels. This verifies our original prediction, that if we didn't have treatment, we would have what the baseline represents. This is called verification, and it's the next element in order to have internally valid design. And this is a simple design, by the way, called a reversal design, which your book talks about clearly. And it's the easiest way to understand this idea of logic. So we now have verified that our original prediction about what it will be like without treatment is accurate. Finally, we're going to replicate the intervention. In other words, we verified that our prediction about the baseline was true. Now, in a similar way, we're going to replicate whether or not we can produce the same kind of changes with treatment. So you can look and see the crosshatch here is that we put the treatment back into effect and we got the same or a very similar result to the first time. In other words, we replicated our effect. This represents an internally valid design. We verified our prediction of what it would look like without intervention, and in a way, with replication, we've shown that predictably the treatment causes change. This is again called a aba2 or a withdrawal or a reversal design. And it's internally valid, means it allows us to make the inference that the treatment's responsible for the change. There's some problems with this kind of design. You can imagine one problem is you have to take successful treatments away, and nobody really likes that particularly. The second issue is we don't really know what would happen if we continue treatment over a long period of time. We've already shown that if we take it away after a brief period of time that things go back to baseline. So there are some problems with this, but it is in fact internally valid, and it provides a good example of a type of ABA design that would be called internally valid and would allow you to say there's a relationship between treatment and change. So, other things to talk about. This is called a within-series design. All our comparisons were made within the same series of data points. We didn't have 2 or 3 series. We had one over time measurement, repeated measurement of the same behavior. It is internally valid, but it's not externally valid. I don't know that if I did this with one person, that I could do it again with anybody else. Maybe there's some particular relationship between that person and this intervention that would not appear again with another person, or another setting with another experiment or another therapist. I don't know. And we talked about other kinds of things. So the reversal design is internally valid. It's not externally valid. But if you repeated this across 10 different people, for example, always getting the same result and with the same kind of problem, then we have more confidence, if you will, that it's externally valid, that we can predictably say this is a evidence-based treatment. So again, this is the simplest kind of ABA design. In reality, if you're a practitioner, you're unlikely to have a complete design. You're probably going to have a baseline and then treatment or variations of treatment. And you might not take the time to withdraw treatment. In school settings, teachers, for example, might not want to stop doing something that's been effective. So we often are not going to be accountable to the point of having internally valid assumptions, but we can be accountable. Here's what we had originally, and we predict that would have continued. Here's what we did, and we got this change. And so we could say, I think this is responsible for treatment. Certainly we can show that there's been an effective change with an A-B design, baseline and treatment, even if we can't say the treatment was clearly responsible for it. The other kind of design I'm going to talk about is probably the most popular common design in published applied behavior analysis research. It's called a multiple baseline design. It's also internally valid. It also depends on the ideas of prediction, verification, and replication, but it's more flexible, and you don't have to take the treatment away. Multiple baseline provides an alternative to reversal design for several reasons. First off, sometimes a target behavior might not reverse if we took the treatment away. This is true for skill building kinds of interventions. If you teach a kid 10 spelling words and then all of a sudden the teaching is over, then he probably still knows those spelling words, and he would not be able to reverse treatment typically. Now there's a way, for example, to examine the impact on spelling by using an ABA-B design, but really the spelling words that one learns aren't going to go away. You have to depend on tests of new words. And sometimes it's unethical to reverse conditions. Things may have been really, really bad or life-threatening or dangerous, and so we were unlikely to want to withdraw treatment. So in these cases, multiple baseline is often useful. There's 3 basic forms of a multiple baseline design that you're responsible for. That's across behaviors, across settings, across subjects. And as we'll see, multiple baseline means that in all these conditions we're going to have literally multiple baselines. So if it's across behaviors, we're going to apply the same treatment to different behaviors. If it's across settings, we're going to apply the same treatment across different settings. In other words, we could do a behavioral intervention for a kid in his math class and his English class and on the playground. That would be different settings, same behavior problem, same kid. Or we could have a multiple baseline across subjects, so we could apply the same intervention sequentially to different people. All of those can produce internally valid designs that allow us to infer or to assert that the treatment is effective and responsible for changes. The reversal design is called, as I mentioned, a within series. The multiple baseline is called a combined series. We're going to make comparisons between baseline and treatment within each data series, and then also between the data series. And we're going to use the same kind of baseline logic that we used before. And it's important to understand that prediction always means we're predicting what changes there would be in baseline if there were no treatment. So we're going to have to look across data series to verify and to replicate, as we'll see here in a minute. So here's the multiple baseline, and this is a multiple baseline across behaviors. So we're measuring 3 different behaviors, all of which are problems. And in this case, we want to increase these behaviors, so they're all perhaps lack of skills or lack of knowledge, if you will. And we're going to ask the question about whether or not some treatment can be responsible or can predictably change these behaviors. So first off, just look at the left-hand part of this graph. We have 3 different data series, 3 behaviors, and we have initially all the behaviors are under baseline, if you will. So you can see that we have behavior 1, behavior 2, behavior 3. They're all under baseline there. And then we could ask, the first question is, what would we predict with behavior 1 would happen if we did nothing? And there's our prediction. And so then we apply the treatment, and you can see that we got a change. So our prediction wasn't true because of the intervention. How do we know that we can verify our prediction? We can verify our prediction by looking at the 2 other behaviors that we did not intervene with. So behavior 2 we did not intervene with, and we can in fact see that it didn't change. And behavior 3 we did not intervene with, and we can see that it did not change. So we verify our prediction about behavior 1 by looking at behavior 2 and behavior 3. Now we're going to intervene with behavior 2. And you can see within the series there, that's the open box, we predict that behavior 2 without treatment is not going to change, but with treatment it did. How can we verify that prediction for behavior 2? We can do it by looking at behavior 3, and that's right down there, the bottom data series where it says A. That did not change. Behavior 3 did not change when we intervene with behavior 2. So in essence, that verifies the prediction about behavior 2. The final behavior, we would predict that it would just stay the same without treatment, but we intervened, and that, lo and behold, we have a replication of treatment effect. So those crosshatch things represent replications. We saw that with behavior 1, when we intervened, we got a positive change. We replicated that change 2 more times with behavior 2 and behavior 3. So now we can rule out other confounding variables. It's unlikely that something else would have been happening at exactly the same time our intervention occurred every time. It's much more likely that it's the intervention that's responsible for these changes. So by using the logic of prediction, verification, and replication, we can produce an internally valid design that allows us to say there's a functional relationship between behavior change and this particular intervention. So in the example we just saw with behaviors, we have different behaviors, the same person, the same subject. Each behavior provides its own control, and after we've got some steady state baseline, some consistent baseline across behaviors, we begin to apply things, and again, once we do that, we apply the second behavior to the third behavior, and within our logical parameters, we can say that, as we just saw, that the intervention is responsible for the changes. If there was a multiple baseline across settings, we'd have the same behavior, the same subject, but different conditions. So we could have, typically we would say we'd like to have at least 3 different baselines here. Sometimes you'll just see 2, but then you don't have as many replications. But at any rate, once we've got steady baseline and the same behavior across different settings, we intervene in the first setting. And then once that effect is apparent, we can look at the next two settings to see that it didn't change, intervene in the second setting, and then the same for the third setting. So applying the same logic we did for behavior, we can use multiple baselines across settings with the same behavior to produce an internally valid design and to draw valid conclusions about whether interventions are responsible for changes. And finally, multiple baselines across subjects. Different people, same intervention, same thing we're measuring. And the logic is the same. I'm not going to repeat it. You can look at this and discuss in your book. The same idea about baselines, about controls, about prediction, verification, and replication, except now we have data series that represent different subjects, same behavior, and we're going to apply the same kind of intervention. There are important assumptions before we would use a multiple baseline. We have to have independent behaviors. In other words, if we're going to do multiple baseline across behaviors, we have to assume that those behaviors are not related to each other. If we do multiple baseline across settings, we have to assume that what happens in one setting is not going to affect the other settings. And if we do multiple baseline across persons, we have to assume that what happens to John is not going to affect Billy or Sue. The behaviors in which we have an interest must be similar enough that they should respond to the treatment in the same way. They may not be exactly the same behavior, but the same kind of behavior. So 3 kids could have 3 different behavior problems that we're going to look at, and that will be okay. But they've got to be similar enough that they would respond to treatment. We have to measure behaviors concurrently, and we have to be able to say that the other variables that we're not controlling are similar across behaviors, or across settings, or across subjects. These are assumptions that could be wrong. But if you're going to do research, these are some of the things that you have to consider before you might choose a multiple baseline as the design you're going to use. You can't apply the treatment to behaviors or persons or settings too soon. You have to wait until you get a significant change. So the baselines could be of quite different length. And this could be a problem for some behaviors that change slowly. In fact, the more the baseline phases are different in length, the stronger the design, because that helps rule out confounding variables. If you're deciding about which baseline or which data series that you want to change first, it will be the one that's the most stable first. But really, all of them should be reasonably stable before you intervene with the first. This is discussed in your book. Multiple baseline is better in some ways than the reversal because you haven't got to withdraw effective treatment, and it allows us to analyze the effect on different behaviors, which is often the case in applied settings. And it also allows us to simultaneously, and I'm not going to get in detail about this, assess some kinds of generalizations. And it's relatively easy to set up. So there are many variations of multiple baseline that you'll learn about in your full course when you take it. But there are advantages in the multiple baseline over the reversal design. Disadvantages. Well, since we're depending on for verification, replication, other settings or behaviors of persons, we never really establish experimental control within any single data series. And that makes it a little weaker. Provides information about effectiveness of treatment variables more so than it does about the function of the target behavior. And that's okay in an applied sense, I think. And it requires that you don't intervene even though you think, since the first one changed successfully, that you've got a successful treatment. So in that way, it's a little bit like a reversal design, and then you have to wait to implement what seems to be an effective treatment. And of course, this requires some additional time and resources, since you're now measuring not just one thing like we did in the reversal design, but many things. So this ends our introduction here. We're not going to talk about alternating treatments or the other kinds of designs in your book. You will talk about those in the full course you have. When we look at interventions this semester, and we will look at interventions almost every week, then we're going to I'll pick interventions that primarily were examined through reversal or multiple baseline design, so you have a better idea about the idea of internal validity, and you'll understand things better. You should, after successfully mastering the objectives of this module, have a basic understanding about research that allows you to read research. We've already read things about reliability last semester, and you can't have a good internally valid design without reliability. We had the article to read about treatment integrity. You can't really make an assertion about treatment unless you can also assert that you really did it. So you have the basic tools, I think, to be able to read research and understand it, and I think in some ways to get more out of your textbooks.